Acid and base definition pH Henderson Haswell base equation buffer integrated normal molarity. Core concept acid base balance achieved by balancing the intake the production to hydrogen ion H plus with a removal from the body. Isotonica, the maintenance of a stable and concentration of blood plasma. Isogatria, the maintenance of the constant proton H plus concentration. Physiological concentration, proton concentration in arterial blood, the physiological concentration approximately 40 nmol L. Conservation L 1 mol million nmol volt or 10 nmol volt. pH calculation using experience the concentration of proton and in the calculator using the formula pH minus logical C plus. Example concentration 48 plus 10 mole. pH is 40 into 49 mole L. pH is equal to 7.4. Normal range, normal physiological range in blood pH 7.3 7.44. An acid is definition of substances that release a proton and hydrogen ion principles. Example hydraulic and acid HCl, carbonic acid H2CH4. A base of substance object of proton to hydrogen ion is bicarbonic acid CH3 and HPO4. The proton in proton also function as base because the quantum amino acid accepted hydrogen ion. Example hemoglobin, red blood cells, and plasma protein, especially albumin, are the most important of the body bases. Regulation of blood pH. To maintain the blood pH at 7.35, 7.445. There are the primary system of three regulation. Buffer mechanism first line deficiency. The respiratory mechanism second line deficiency. Renal mechanism third line deficiency. The first two lines to hydrogen ion concentration of change of much handle the more than slowly. Respond to the third line to deficiency that the kidney can eliminate the excess acid or base from the body. Normal pH of the body fluid. The normal pH is arterial 7.4, whereas pH venous blood when interstitial fluid is about 7.35 because the extra amount of carbon dioxide released from the tissue from C2CO3 in the fluid. The pH blood maintains remarkably constant level 7.35, 7.4 by normal pH fluid. Body fluid pH. Arterial blood 7.45, venous blood 7.35, intestinal fluid. Intrafluid urine 6.074, gastric CHL 8.24. Respiratory physiology. The attitude balance through introduction by attitude balance of the human body, the critical respiratory maintenance of ensure the proper function of cells and organism. Hydrogen H plus concentration of body fluid, particularly the body blood. pH within the narrow range of 7.35 to 7.45, average 7.4, which is the oxygen delivery protein function overall the cellular activity. Hemoglobin loss of affinity mechanism, medium and not fully saturated and alkaline medium. In addition, protein must charge order the loss of configuration of function. Release of thiamine mechanism, chemical buffer, the respiratory system and the kidney. To neutralize excess acid bases to respond to physiological change and restore equilibrium. The further failure becomes the overfull danger. Acid-base disorder such as metabolic or respiratory acidosis and alkalosis is required to promote regulation and management. The physics Venous pH and pH in intercellular fluid is 7.35. There are lower pH equal to intracellular 7.0 is equal to 100 nmol. The pH compared to arterial pH is different to 0.4. 2.5 fold the difference between the intracellular arterial pH concentration. The concentration gradient movement is the H plus from cell to blood. The change protein structure, membrane permeability, electrolyte distribution. Type of the acid found in the body. Well, the disorderly respiratory and the level body the external respiration carbonic acid. The organic acid to include the lactic acid to flat acid and ketone body, acidotic acid, p-butyric acid. Inorganic acid to include the sulfuric acid, hydrochloric acid and phosphoric acid. Ketogenic products in the ketone body, fatty acids equal to ketone body plus N plus H2 plus. Lipolysis and de-aging glucerase, arginine, CO3, NH plus, urea, H2O, 2H2 plus. Urogenic CO, carbon dioxide plus 2, NH4 plus 4, urea plus H2O, and 2H plus H plus. Normal value acid base homogeneous physiological ranges of the pH 7.3 H plus production equal to H plus loss. 7. Article donated alkaline pH lower than 7.3 is acidemia. Acidemia is more than common due to production metabolic activity. The pH value catches serious consequences. For example, change of protein structure, membrane permeability, electrolyte distribution. A source of acid-base acid products. Most acid carbon dioxide production will have the quantity through the carbonic metabolic. 50,000 to 20,000 milliliter carbon dioxide a day. Become the acid is reacted with water H2O blood thermoproduction facility of carbonic anhydrous emission. Carbonic acid which is called to plate hydrogen ion and bicarbonate. The hydrogen ion temporarily blind the hemoglobin in the red blood cell. The blood reacts to lung oxygenation will catch the hydrogen release. The back to carbon dioxide and water. The carbon dioxide is then expelled, the water is eliminated by the kidney. Glucose and Canderblanc has blood places. Hydrogen has blood places. Glucose can be written by pH plus logic 10. Glucose and donated molar concentration of constitutes pH, the acid and HA donated molar concentration of weak acid. The hydrogen equation of HPHPOKA long conjugate base bar acid. The equation could calculate the pH value, therefore solution by the equation American chemistry liaison to Joseph Henderson. The equation is expressed to logarithm from the Danish chemical Carl Albrecht Archibald results in the named Henderson equation. Derivation the hydrogen equation. The ionization concentration strong up term can be calculated with the help of the direct method. The used weak and acid base since I attend to ionization change acid base is very low, weak acid and base handle ionization. To approximate the pH there type of solution Henderson equation used. Elimination Henderson. The Henderson equation fails occurred strong gas space and because the accumulated concentration of the acid conjugated base of chemical equilibrium remains the same formulation concentration. That does not undergoes in water. It is failed of offer accumulate pH value extremely dilute buffer solution. The Henderson HW equation related pH solution of the concentration of weak acid and concentrate base. The critical tool of understanding buffer system and titration curves. The derivation summary equation and derivation acid association were considered Ka. This association of equilibrium HA equal to H plus A minus Ka expression A Ka H bracket HA rearranged for H plus Ka H minus logarithm conservation apply the negative logarithm path side converting concentration into the pH pKu unit. Final formula the final common equation pH pKa log A minus HA considering item in return the proton acceptor proton donator. The calculation fees with pH of the proper solution during the titration. Titration curve provided mathematical basis for the shape of the titration curve with the weak acid buffer descent help in the determinant acid base needed the rise of the titrate pH. The weak acid weak base. The weak acid particularly ionized water and release pH plus ion lower than solution pH. Weak base accept pH plus ion increase the solution pH. Extend the ionization of weak represented it is dissociation constant Ka. A Ka strength of the weak acid and indicated the pH of equilibrium formula. The lower formula is stronger the acid, higher pKa, stronger the base experimentally pKa determined in the pH midpoint the titration curve. The buffer solution made of the 0.4 pH only. Displacement concentration formula with the buffer solution. The Henderson HW equation pH Ka logarithm. Substitution is well way of it. pH to 0.4 the logarithm 0.6 m 0.4 is equal to 1.7 log it. 1.5 is 4.7 plus 0.17 is equal to 4.87. Therefore, the pH solution is 4.87. Acid base homogeneity P is around pH 7.3.74. Water carbon dioxide to H2O3, Hc plus H2O3. The carbon dioxide level reach more than carbonic acid form additional hydrogen ion and the bicarbonate ion is related the pH goes down. The another towards H2O3, H2O carbon PCO2 pH. The PCO2 fails reaction the Rancher with the carbonic acid discharged in the carbon dioxide water. They remove the ion plus ion from solution there increase the pH. Four factors involved in the maintenance of the acid homogeneity. The respiratory system plays in the role of the eliminating carbon dioxide first only. Active tissue the continuous general carbon dioxide with solution from carbonic acid. Additional acid to such lactic acid are the produced in the source of normal metabolic operation. The second only the respiration system plays the key role in eliminating carbon dioxide. The third only the kidney play a major role of the secreting hydrogen ion into urine and generating buffer into the blood form. The rate of the excretion which the file needed to maintain normal plasma pH. The normal pH of the urine average the average is 6.0, slightly acidic. Last four on buffer system can temporarily store H plus and therapy provided short time the pH stability. The normal range of carbon dioxide normal pH 7.35 7.444 buffer system. And molarity is the mole of the solid vapor of the solution, mole of the um, solid and volume of solution in liter. Molarity the second only the not mole of the solid kilogram the solvent, mole of the solvent, weight of one solvent in kg, molarity. Normality measures gram equivalent weight per liter solution. Gram equation to solve volume of the solution in the liter. Fourth only formality is the number of the gram, formula mass, ionic solvent dissolved in per liter, solution weight in gram, formula weight plus volume of the solution liter.